Rebecca, are you already here?
Tasting. Hello.
Becky? Hello. How you
I'm having
doing?
technical challenges here.
Having some challenges? It's okay, we'll overcome them. Is this it? Did we do it?
Yes. Okay, you can
Okay.
share.
Okay, hi everybody. I'm Rebecca Taylor, and today, okay, no, sorry, Rebecca, you go
Yeah.
for it.
Okay, so you can share it full screen.
Yes.
Um, yeah. So basically, yeah, as you said, I'm Rebecca, and I'm a I'm a tech lead at Lidl. So like Lidl e-commerce, and yeah, like we have many models in production and many different architectures for them and different use cases. So I'm like specifically on the personalization side. Um, so basically, in general, looking at how can we make the user experience better using data. So today I'm going to just speak about like some considerations when it comes to choosing a ML architecture and yeah, like some basic examples of what you'll currently see. So you can go to the next slide. Okay, so as we all know, it's getting so much easier to like build actual models. I mean, 10 years ago, there weren't like probably 1% of the packages that are out there at the moment. And there's also so many like resources and boot camps everywhere. And, you know, even on the data engineering side, there's so much out there that's available. But I think there's maybe a bit of a gap in terms of what actually is there in industry and what's the current state of industry and the kind of constraints that you'll run into. I mean, you can build these insane models, but to actually have them living in production and signed off and, you know, making money for the company, um, you know, what that actually looks like, at least in Germany, is not necessarily what you might have in mind or be as flexible as what we would like them to be. Okay, so you can move to the next slide. So basically, some of the things that will really influence what you end up building, I'll talk through some of them, but one of the biggest ones I've seen practically is the team structure. So different companies have different structures, and I was in consulting for about 5 years as like an ML engineer, data science / data engineer consultant, and basically what I saw is that there's such a diverse way that companies set up their team structure. One of the common ones is that you'll have kind of like the data scientists all sitting together, building their nice little MVPs and kind of having these proof of concepts and also doing a lot of maybe analytics and things. But then they kind of hand over their models to like an ops team or like maybe MLOps, maybe DevOps. It depends on the maturity of the company if they even have an MLOps team. So sometimes their models are actually not even used as is and completely transformed by another team, right? So you get a notebook and, you know, they hand over a notebook and this model gets completely kind of redone and productionized and deployed. In other cases, the data scientist is responsible for kind of giving a model artifact and maybe some config files or whatever. And then there's like slightly less done on the operational side. In some cases, your model that you make will be used basically just like in a non-production environment for a while to test how well it works, and then it gets changed into a totally different language and deployed. So that's some of the things you really have to consider. I think the stack is becoming slightly more coherent. Well, slightly. And I think one of the things that I've seen a lot more lately is kind of a product structure. So you have kind of like a mixed team where you'll have like in one teams like data scientist, data engineer, ML engineer, even some devs, business analysts, and they'll deliver like end-to-end systems. So this is what we have for part of the business in Lidl at the moment, which is quite cool because what ends up happening is we're responsible for basically like parts of the front end all the way through back end data engineering, ML engineering, feature stores. Well, not like the infrastructure as much of it, but like what ends up in the feature store, you know, pieces of the data lake that we own, and the whole tutti. So even, you know, the monitoring, alerting. So like as a team, we're responsible to deliver stuff. And yeah, that makes the collaboration quite interesting. The challenge there is when you have a lot of models in production, then who maintains them while you're the same, you know, people that are building the new models. So what often happens is you also have like an ops team that's like going to be on standby, and they'll also be briefed on how to handle these models and stuff. But basically, if you don't have like those kind of mature setups, then you actually really have to consider carefully what you put into production and what your design is, because if it's not going to be able to be maintained properly, and if there isn't correct alerting, and also like change, like as your model, if you want to retrain and do like significant changes, you might not get the budget to do that, right? Because there just, isn't that option. So yeah, and oftentimes like the ideal model never makes it into production just because of these type of team constraints. And then another constraint that we often like run into is that there's like predefined tools and tech that you're allowed to use, right? So you might be super experienced with a certain stack and you join a new company and you realize, nope, you're not allowed to use that. There's specific things that you're only allowed to use. That can also be, for example, from like a location point of view, cloud services. You might want to be building the coolest new Gen AI model or using it in some way, but it's only available on like GCP or something, or AWS, and not Azure, just for example. Also from a like an integrations point of view, there's certain things that work well together and others that maybe don't work as well together. And if you have bad luck in terms of the architecture decisions of your predecessors, you might be forced into combinations of tools and tech that actually are difficult to work with. And then a lot of time is spent kind of gluing things together, right? So yeah, I think that's something that also could be surprising if you're new to the industry and realizing, or new to a different role. I mean, this is actually maybe a tip for if you're going to choose a new role, to really ask questions in those interviews, right? So yes, they're interviewing you, but you can also interview them in terms of like the tech stack, and ask detailed questions about that, and how, like, I mean, do they have an in-house ML platform that they're maintaining and building? Are they using something that's already like tried and tested, existing? Like, are they using a more flexible type, like for example, like ZenML, or are they like locked into something else, right? Like Azure ML, for example. Yeah, those decisions can significantly impact like your designs and what you end up being able to build. Also the industry, and business requirements, so that's super important. Like, I mean, in some cases, yes, you can build a nice data science model that pulls features from like some cloud storage, and does a prediction and sends it back or whatever, and that will work for you, right? But in other cases, pulling from storage, for example, is just not going to cut it. You're going to need much more low latency solutions, and you'll need to be putting caches in place. And often like on our side, basically we have quite advanced caching systems on our website as well, which means that you'll be caching things on your side potentially in your model APIs, but there's also front end caches that you have to consider, and you also have to look at like what those kind of systems do. So this is something that like can really constrain your design, especially if you want like near real-time features. Some of those features aren't available in the way that you think they are from certain systems. So if you're in a situation where the actual full design of how events are happening in your front end, this is just in like an e-commerce or banking maybe example, if that isn't set up in quite an advanced fashion, like maybe you don't have a proper Kafka solution or something going, and you can't access the events in time, it can really constrain your design, and you have to get quite creative of how to still deliver some good business value, even with these constraints in mind. So okay, you can move to the next one. So here's just some really basic patterns. So yeah, this is the example of you have a model, you want to perform inference on this model, and what are some of the ways this will look, right? So the most kind of easy, obvious one is a batch scoring job. So basically your input is like data, multiple tables or whatever, and your output is also a table, right? So that's the easiest. That's nice. You can have an interface where you are just putting your things into a table, and downstream gets to consume that and serve it and do whatever they want with it. Or maybe it's used for some forecasting or some pricing models or predictions or something, reports. I mean, that's the one that like, yeah, it's easy and there's normally no issues. Then in the case where it's also batch scoring again, and often you'll see batch scoring in like marketing solutions, right? They're like, here's all our clients, or let's run some batch job and do some prediction or clustering or something like that. Same also in like banking for clients, they might have some, like, for example, if you're looking for patterns of fraud or things like that, sometimes they'll do general screening batch jobs that will just run, and then there can be analytics done on top of that. So if you like in that space, that's quite nice. But then the one step up from that is normally like if you're also doing the serving side in terms of like the results. So it can still be like a batch scoring job. So the results are written to a database, but you also expose those that database. Basically, it's the information of the database is then accessible by an API. So you'll basically just have some like GET request, and you can then pull the model's results, either for one like instance, so one client or one whatever, or for even a batch of them potentially, right? But it's available by API, and then that's easy to consume from other services. And then the slightly more tricky side is when you need to have prediction kind of on the fly. So the prediction part is real time, not the features, but the actual prediction happens real time. And this is very common when there's any type of data science happening in websites, right? So the person will be clicking and doing things, and based on what the current state is of this person, of this customer, you then want to make some prediction, right? And the nice case is where everything that you need for this prediction, so all the features, not necessarily like pre-processed features, but at least the raw information for the features, if those are available, by the front end or in that layer that's calling the API, then you can just have your model in the API and just run predict and get an answer, right? The problem comes in, and that's the nice one, right? But often this isn't the case, and you have additional sort of historical or slower moving features, or features that you have to get from somewhere else, and that means that you get some of the features in your payload, but the rest you have to get from somewhere else. And when you have to get it from somewhere else, that's normally going to be there's data engineering jobs typically that will get it to the place you need to read it from. You'll probably have something like Redis or some caching layer as well, or I mean maybe you're using something like Mongo, which also has a bit of caching built in. This is where you have to also worry about cost a lot, and basically tuning this sort of online feature store, basically, right, to handle like what loads you need and what latency you require, basically. So that's sort of the harder one, and it gets harder as like you even move into, as I put in the last point, like really hardcore streaming stuff. So if you have like a full-on real-time transport, that's used in a prediction sense as well. So that's not as common, really like used in industry. I think you get most of the value already by the first points. Okay, we can go to the next one. Wow, this is really small. I'm looking at it on my phone. So basically, this is just like a batch scoring example with a little bit more detail. So this is the simplest case, basically, where you'll often have like multiple data sources. I mean, I just showed two, and then you have some transformations and mapping jobs and things like that, and then combination of the sources. And then like in our case, we're using like Unity Catalog for our like data lakehouse thing. But yeah, so you have some tables, like, or maybe one table there, and then you have a batch scoring job that basically has access to your ML model, and it just predicts basically over all of those entries. And obviously these jobs, all these blue jobs, are data engineering jobs, and they will then be optimized as well, and the clusters that you're using to run them on, if you're using clusters, will be tuned and like customized for the actual code that they're running on to save costs. And then, because often this is a lot of data that you're working with, right? And these jobs if you write them badly, they can take 2 hours. If you write them well, they can take 10 minutes or something, or if you optimize the cost, there will be huge differences, right? Also using things like spot instances, if you're in Databricks, please, do that. So, where you can, if you're doing a batch scoring job, for example. And then, so once you're there, then you typically will, for future analytics and for, traceability in future, you'll write these predictions to a historic table. I mean, you can also have different data modeling ways of looking at things, right? So you could also have one table, but, when you pull the data from it, you can just pull the latest. But often storage is cheap and compute is expensive. So we kind of just have a historic table, and then we have a current state latest table. And then in our case, we have a job that writes that to Mongo. And then you have a prediction collection in Mongo that you can look up. And obviously there's all the partitioning things that can come into that. It could be multiple tables. You can handle it how is needed to be handled. But this is just an overview of what often is used. Okay, and then next one. So this is now the serving part of a solution like this. So this is basically an example where this API will have a model inside the API, right? But it will also have data that is being pulled from predictions basically that have already been made, right? So this is also a common use case in something like e-commerce or banking, where you have customers and you'll have like old customers and new customers. So in some cases you have people that you have data about, lots of data about, like historic data about, purchase data or whatever. And in other cases you don't. You only have the real-time features that from their current clicks or whatever, or maybe just some information about them, right? That's available from the front end. So you'll actually have like the model in the previous slide making these batch scoring predictions, but you'll have a different model that hopefully does something very similar, just with less data, and it will then make a prediction for everyone where you don't have the historic features for. So basically, if it's existing user, you pull the features that you have already or not the features, you pull the predictions that you've already made directly. In that case, you can end the loop and return with a lower latency. Well, not necessarily lower, because yes, it will be. Am I coming to an end?
Yes.
Okay, I'm basically done. Okay, but in the other case, then you have to still pull the features and make the prediction, and then you can return. So just in closing, maybe go to the last bit. Yeah, I'll just summarize saying that basically, you have to really think about many things when you're doing your design. Keep things as simple as you can, build on that, make sure you're getting value, and speak to people that have done stuff before.
Wonderful. Rebecca, thank you very much for this. I love these types of presentations to just give me like a sense of context and overview about like all the different things, even just to make me feel less crazy for picking something that starts out a little bit more basic before going to just like a full or kind of like more heavyweight solution. So thank you very much for that.